Okay, for this heat conjugate heat transfer, I've already opened the file and we can create now a flow simulation. Let's rename the project conjugate heat transfer. Then click next. Then the unit system is under user defined USA Electronics. I've already practiced it a while ago. That's why I've already had this USA Electronics, and the unit is in English. The main unit is in English, but the heat is an SI unit. Click next. Analysis type internal. Exclude cavities without flow conditions, and heat conduction solids yung physical features. Then click next. For the fluid, I've used air. According to the PDF, we should use air. Then click next. For the predefined solids, under alloy, let's select stainless steel 321. Click next. Then the wall is not adiabatic, so the parameters of wall has heat transfer coefficient, which is equivalent to 5.5 and a temperature of 50 degrees Celsius. Then click next. And under initial conditions, let's change the temperature also to 50 degrees Fahrenheit. And solid parameters also. Then click finish. After that, hide this computational domain. Then insert condition. Under condition, insert fan. Under the fan, let's select this lead face, inner lead, but we have to trim some part. So let's filter, keep outer and fluid contacting faces, then delete some more and more until that. Then under fan, a predefined on axial fan, which is POPs 412 according to the PDF. Then click OK. After that, let's insert a boundary condition. Under boundary condition, select the outer lead and outer lead and all outer lead. Just click that face and explode this and filter it to keep outer and remove, so that the non-contacting faces would not be included. Filter it, keep outer fluid and remove outer face. After that, go to pressure openings, environment pressure, then click OK. After that, we can insert volume goals. Volume goals for the main chip. Main chip is 5 watts. Then another, let's rename this main chip. Then another volume conditions for the all the small chips, and it has 120 degrees Fahrenheit and for watts. Then click OK. Another is for the volume source of the capacitor, which is equivalent to 100 degrees Fahrenheit. Let's select the three capacitors. Then click OK. Then let's rename these small chips and capacitor. Let's delete this first. After that, we can insert solid material. For the main chip and the small chip, let's select that all. There's already a created user-defined, which is the tutorial component package. In this, the tutorial component package has already had the different parameters such as density is 2000 kg per cubic meter, 120 joule per kilogram specific heat, isotropic, and so on. Then save and click OK. For another solid materials is users defined tutorial PVC, which is consists of the PVC1, PVC2, and the board. And as similar from a while ago, I've already made it, and it has different parameters unlike the tutorial package. Then click OK. For the heatsink, insert another solid material. Heatsink is an heat insulator. Then click the heatsink. Okay. After that, we can now specify volume goals. Let's specify global goals. Static, average pressure, and total pressure. Let's check the file. For the volume goals, temperature of solid. For GG goals, where is the GG goals? Global goals is static and temperature of fluid. Static and temperature of fluid, then click OK. For the volume goals, click this, insert volume goals, and what we need is for the big main chip is the temperature of solid only. Temperature of solid average. Then let's rename this main chip temperature, BG bit temp of main chip. Okay. Another is the click this pre-select, so we won't be it would be pre-selected if you create another volume goals. Select again temperature of solids, then click OK and rename this to temperature of small chips. Okay, and for the capacitor, after that, small chip, main chip, and for the surface goal, let's insert surface goal. Let's click the fan, then insert surface goal, average static pressure, and click OK, and rename this inlet AV static pressure, then click OK. Uh, After that, we have already, we can now mesh and run. But first, let's define this. Let's edit this into 0.1 inch because the gap of the heatsink is around 0.1 inch. Then click OK. After that, we can now run the simulation. Click run. Okay. Now let's wait for the computation to be done. And while we're waiting for the computation, let's review the PDF file. External flow, temperature of solids, max flow temp, tutorial PVC, then solid material 120 and 4 watts, small chip, PS. Okay, let's just wait. Then environment pressure. We forgot the mass flow rate parameter. Hmm. Let's stop this for a while.